Okay, this is a video to show how to use a DVM to do continuity testing. Most all DVMs have this feature. Usually a little speaker icon. Just turn to this position. And then when you touch the probes together, when there's continuity, let's see, there we go, beeps when it's not touching. If you look at the printed circuit board for the tubes, you see the lands are labeled around the outside edge. I don't know if you'll see them on the video, but they're basically ground, data, and 12 volts. And let's just put our probe on the 12 volts. They're the ones with the holes in them. Let's put it down. Let's put it here. And then all the 12 volts are in parallel. So you can see how it beeps. They're not short of the DI, not short of the ground. But all the way around, the 12 volts are connected. Similarly for the ground's on the opposite edge. So if you go around those, see they're not shorted each other to adjacent lands, but they all are connected. Like that. Now the data, half on one side are connected and half on the other side is connected. That's because the driver can't drive all 14 or however many there are in parallel according to the spec. So I divide it in half and have two drivers. But you can check this half, but that's not connected. Well, I don't know where the division is. Well, hold on. I guess I guess they all are in parallel. I thought I put them on two. I think at the heat tracker, I think they're on two, but I think they can carry, they can all carry on one on this guy. So anyway, when you're going and doing your lead strips, these have solder joints on them. And so sometimes it's a little hard to probe on that. I mean, you push against it, but it won't really be making contact. I guess because there's flux on there or some contamination. So a lot of times what I'll do is I'll put it on adjacent land. And then if I have other spare lands on here, or even on the one, I'll probe on the one that it's supposed to be connected to. So let's say there's solder blobs on here, and I want to hear a beep there, but I do not want to hear a beep there. And then similar here, if I put on the data, I want to hear it there, but I do not want to hear it on the adjacent pins. So I have a new solder joint here with my 3 blobs on there. So I'll go here, got it on ground, don't have it there. Put it on the data over here, got on the data, but not on either side. And then finally with 12, got it on the 12, but I don't have it on the adjacent side. You'll never have it there. And that's really all there is to it. The main thing is, if you ever have a bridge between 12 and data and you power it up, you'll fry everything on this board because every single one of these strips will have 12 volts connected to its data input. And that will fry it spectacularly. If you short the ground, nothing bad will happen. It just won't power up. But, you know, visually inspect it. Is 99% of the time that'll catch you until you start getting good and you really start, if you're like me, you really start cranking them out. And you get sloppy. And what I'll normally do is I'll put like 3 down, 4 down, and then I'll make sure there's not any shorts using this, and then I'll power it up. There still could be a defective strip or something that there's a problem on it, and that'll maybe bring all of them down. Then you got to unsolder them one at a time to figure out which one has the problem. You can do them one at a time, and then you always know it's the last one you put in, but every time you do one, then you have to take the board up, plug it into your tester, which I still need to send you one, and it just takes longer. So it's just all about whether you want to take, you know, an hour to 2 to build a card, or you want to take 3 or 4 hours to build a tube.